Okay, I got this to behave now. This is a new chamber I made, a shunt bar black sand chamber. So I have one up here and one below. And what I did is I made this gap between the top of the crossbar, just like about a 1/4 inch gap. You can see up here too. Is why bring the shunt bar way up high and then over and then down. I did that. I was doing that to make a lot of winds around the shunt bar. I didn't see that really made much power, so it seems like there's a shorter length for the back EMF to get over to the other side. And Tim Tron was saying that when he had really thick shunt bars, it didn't work so good. And those last ones I had were really thick. And what I'd done was the crossbar, all this laminates on this thing are 1 inch thick, 1 inch, 1 inch, 1 inch, 1 inch, 1 inch. So this crossbar is 1 inch. So I took that magic number 1.618, and that's how far I made it larger than the crossbar. This was 1 inch, so I did 1 times 1.61, and so I had a huge, thick shunt bar. And but this time I went the other way. I divided by 1.168. So the shunt bar going across is about that wide now, like 15 millimeters. And where it meets the crossbar, it's I'd say there's about a 5 or 6 millimeter gap between the top of the crossbar above the primary, because the whole idea, is to bypass the primary, the back EMF, and bring it all the way over. So I was thinking, why not just have just like a 1/4 inch gap or 5 millimeter gap right here, air gap between the top of the crossbar. So that's what I did. So I have a new shunt bar. So like I was saying, this is filled with black sand inside of here. Now I got some over unity numbers, and why I was really frustrated is when I have a 12 UF cap. This is a 13 UF cap in series from the primary into the primary from the grid. And when I was doing that before, I would have no phase shift. Something happened to those laminates. Now I'm back to having a good phase shift with a series cap. And I calculate this at 74 degrees phase shift. There's like a 4 space gap between the volts and the amps, 4 spaces, not a square division of 5, but about 4. And one complete cycle is 19.5 spaces. So 360 divided by 19.5 is whatever that is. A little under 18 degrees, and then you times it by 4 and you get 74 degree phase shift. That's what I have here. My calculations. I took a photo, froze it, and looked at it for a while. So a 74 degree phase shift is can you read that? Is that number 0.27. So if you calculate the amps going in, it comes to like 1 amp, because there's I'm into 0.05 square divisions, so every vertical space is 0.01, and there's like 25 of them. So if you do the math, it comes to about 1 amp coming in, and it's 120 volts coming in, so 120 volts times 1 amp is 120 VA, and if you go here and times it by the power factor, that's something like 30. I'll do it really quick. Sorry, 120 times 0.27 equals, yeah, about 32 watts input, because it's 120 VA, volt amps, times the power factor of 74 degrees is 0.27. So this is good. And look what I got across the resistor, 70 volts. And it's an 82.7 ohm resistor. So 70 times, just 1 minute. Okay, so coming out, since it's 70 degrees across a 82.7 ohm resistor, so it's 70 times 70 is 4900 divided by 82.7 gives you 59.2 watts output. So that's okay. 32 in, 59 out. Still not double. But at least it's behaving, and when I put a series cap in and boost the amperage, boost the output coming out, it has a good phase shift. This is how it was before, and then suddenly it just stopped and it just went to no phase shift at all, completely in phase, which means there was no power factor. I think the laminates had vibrated and all the varnish off, and it was just a solid piece of galvanized steel. That's all I can think of. But so it's dropped down to 69 volts across the resistor. And here's the resistor, 82.7. So I made not such gigantic shunt bars. So guess that's about it. Okay, thanks for watching.